Welcome back to Wickerson Studios. Michael Wickerson here, continuing with my favorite GH scripts that got me started in Grasshopper. And I'm going to go on to this 21 script, and I'll be running kind of the odd sets of tens, I guess, if that makes sense, 10 at a time. Now, Buckman's book is pretty fantastic. This one's pretty simple, and we'll just jump in here and show what's happening. Circle through perp frames, which can be displayed at a much smaller setting for this. We'll just do it at 2. Um, Circles on those frames, and then points on those, lofting this in a direction, even though I can shift list in this direction and step it like in different patterns, but I'll leave it at -1. And if I'm going to take it through an iteration, I can either have this geometry driving this loft, or I can have this one, which is actually curves closest points driving another curve closest points to a surface evaluation with an evaluate curve, and then cross product to find the normals. The normals then inform all of these wonderful rectangles, which are parametric through their size and scale, and then lofting through those scales. Those squares are totally different. What a wonderful script. Total credit to that. And I think I just put this on here to see what was coming out as closed breps, because even baking this, you still have a few problems when you go in here and then you try and take these into a Boolean union. You have a little error here, and it probably won't complete the Boolean union. Yeah, it'll fail. So you have to find another way to kind of bring one into the next and eliminate these kind of errors that occur. So it's not a perfect script, but it's certainly something that got me excited about Grasshopper. Now the next thing I'm going to go in and I'm going to open what the next one would be, and that's Weaverbird, and I have this in full. Weaverbird in full is a script that most people are accustomed to seeing. Let me get rid of this one from the last script. And I've made this into a world, into Unity, to play and run around and knock things around, but it's really good exercises. I'm not going to go into detail on it because you really need to download it, load it up for yourself. I think it was through Yak at this time. What was the date on it? It was quite a while ago. But basically what you have is a really nice use of Catmull Color, finding the edges. The first ones that have a hexagon pattern. The second one is an evaluation of a surface with colors, which is pretty simple, with mesh colors, which is set. The third one is a Weaverbird kind of meshed window, which actually isn't the most beautiful example, but you can see that you have control over that, kind of offsetting it, understanding what it does. And then this one is over here on this mesh, bringing it out and finding a surface kind of evaluation of height map with colors using the loop subdivision on a mesh. And that mesh is pretty simple to start, and you can see what subdivisions do to meshes like that. The last one was all these three objects, which basically started with this one, producing that from a mesh, going through the different iterations, and then this one to complicate it a little more. I think that was the final one. This was the second stepped one, which is a little more complex. But when you get to this final, and it was the Laplacian model. What's nice about this, and I realized this from, I'm trying to remember the guy out of Chicago in the architecture, you can actually have multiple sliders here that inform. You can actually shift and control these in, and this was a little subtlety that I thought was pretty cool. So when you end up, when you end up taking these into multiple levels, you end up getting this really cool kind of script that does a lot more than what you might have been used to. So I can take that down to the 1 to change it, and I can take it to the 2, and it will have a major effect on this. But I'll leave that off for now. So Weaverbird I'm just going to leave open as a wonderful little world to explore and decide what you can do with these forms. Definitely a great plugin and a great script to get you started. If I go on, I'm going to go into HoopSnake for a minute, a very simple example of that, running a function x times x through a loop. And to get that started, the trigger, I can set the trigger on, I think. But here with HoopSnake, you have to run the script. And if you do that, you can see that this is running through 3 iterations. I want the trigger to be false. I think as I run it, it should go through all 3 examples, 3, 9, 81, as it multiplies through up to a maximum of 100. And you got to be careful of this because it can get away on you right away, but it's a really nice feedback loop with a hoop snake. Close to anonymity, and we'll talk about that at a later time. Then we get into something that's more advanced than the original Grasshopper, in my opinion, and it was done by Benjamin Fulbrecht. And this was the real clincher to why I fell in love with Grasshopper. So I've got three scripts here. The first one, FlexHopper, you can see how magic it is. This little tiny area right off the bat. What is happening? They basically build a point system, which is just fantastic, and does a little bit of do-si-do of moving up the 100 domain end. It's a really nice technique to keep all the points above the ground. Otherwise, this would have balanced. Without this, you would have seen that this would have went X, Y, Z and been here, and only the top points would have fallen to this X, Y plane. So that was a nice little subtlety. So you really got to pick this apart, and then you're taking the particles into points. So it can be interpreted into these C# nodes that are written from the flex scene to the flex collision points, which happens to be that plane we were talking about, which is just represented by a point. Then the solver will solve it, and you set it to true, and you hit go. And of course, you have to be looking at your outcome to see that. So let's do it again. Start, and you have this falling action. And then there's a couple things here for flex solver if you want to change the time step, or if you want to change the scene mode and things like that. But nice to get you going on FlexHopper, and it gets wonderful very quickly. So back in the FlexHopper for the second script that I pulled out, and there's many. These are colliders, and you can see within here, and I think they've taken off the visualization, which is heavier mesh spheres. But as you get through here, read through it again. You want to activate this play, which is nice, and over here, there's actually a tool when this is activated that's actually running. If I set my program on and turn it on, you can see that I'm firing these particles and they're hitting off these colliders and then balancing against this kind of basin of planes, so they roll back down to the bottom. But you can set that in a continuous loop off of this timer, which is just shoot, shoot, shoot. You can rotate that from different sides to shoot the particles from. They imitate water. You can change the speeds of those. The particle count, you can change the z component of the height of that, of where it's emitting, and you can start changing the velocity of that to change it as well. And you certainly can play with the radius of that if you want to throw those points out a little more. What a wonderful simulation to start making point clouds and making geometries. I think the rest of it, the colliding boxes, and then the sphere, I thought that, no, this was the one that is playing off of, if I wanted to go off of this, these vectors are, thought it was a mesh ball. Let me turn this on. Yes, it's a mesh ball that actually has vectors in it that point in. So if any balls get caught up in this sphere, they actually get set to that sphere. So let's reset it. So this ball is kind of here, and if anything actually ends up colliding into it, you'll see that it rotates and gravitates to that ball and stays within it. And of course, it's a little below the plane, so it still has to adhere to the plane in it. Let me see if this one's grabbing. Pretty nice scene mode. Let's just go back to the sphere, the X shape. I think the Z, I can change the radius of that so I can see how it's catching it, and I could certainly set it up in the X, Y, and Z directions. The vectors being controlled by that. Really nice use of meshes and cleaning them up. And if you do need help with the FlexHopper, you're going to want to set your display to full names, and then in doing so, you kind of move things around so you can read everything that's happening. But double check all your inputs, play with that. You see that this is getting pretty heavy by the time I've done it. So really nice scripts. All of a sudden I'm going to turn it off, reset it, and have it ready to go. And then the last FlexHopper that I brought out before going into Kangaroo was this one, which is my favorite because when I saw this video I just about died. It is a surface, it's a mesh that's set to true. It will behave with wind and velocity, but respond to colliders. And the collider itself, they do warn you about this second. I think I did it twice. I kept it one running well, and then I cut and copy it down here, and then I play with this one just so I don't screw it up. But this is kind of nice. The vectors controlling the wind. You've got the parameters that are playing into here that you can change the velocities, the wind drag, the lift. And let's go back to that object. That's pretty easy just to sit here and have the Z and have that ball kind of push through and break that mesh and kind of bust right through it if it has to, and then push it up from the bottom. So when I saw this, I was just like mesmerized with this being possible. And of course it continues with FlexHopper, and it comes out of the Kangaroo. And I'm going to take a look at the Kangaroo. Well, before that I'm going to take a look at Catenary, which I think comes out of Kangaroo, a pretty simple solver. Let me get rid of this and put this on true trigger, And I'm wondering why this has, oh, I'm locked up in my, let me get rid of that mesh. Let me go back down here. This is a nice little sample of the trigger to true, and then play. And then what you have to do, I think this slider, no, this slider was 0. It's going to pull down in the down direction. I should be able to toggle on, and there it goes. It'll fall. And with that, I can play with the pressure. This is going back to Kangaroo and making it a little simpler. If you want to start playing with fabrics and anchors and springs from line, but keep in mind that this is actually Kangaroo 1, and it's not the Kangaroo 2 that comes with, I believe, Grasshopper, Rhino 6 and 7. So that's a nice little simple one to get you started, but once again, things get complicated very fastly. That was the catenary. I'm going to go into 27 here, and this is the one that I'm going to, I think, set this to true, see what I have as geometry. I've got a mesh here. Now what I would do here, I keep trying to take this off, is sometimes I like to put things to subdivisions, but whenever I do that and I want to calculate something first, I'm going to put in a data dam, and I should save it as this. So that data dam, when this is correct and this box is actually done what Kangaroo wants it to do, and I'll show you an example of this, of kicking it off and hitting true, it should hold its form once that data is kind of collected, because it's still jiggling and moving in this way from the physics solver, and it's using a spring from mesh, which has to be used on almost everything, but a simple mesh coming through and cleaning it up with combine and clean. And once again, I would recommend going into drawing full names on each one of these so you can see what's happening. But when that is done as a geometry, then you can put it through the data dam and then take a look at, say, something like your subdivision form. That would be very difficult to script in any other way except for this physics solver. So then we're going to open up 28, and I'm only going to go to 30 on this. The next one that gets a little more complicated, this one was, let me think about it. Oh, it's a nice tented structure, which allows me to think about the poles and think about the points driving that as points. So this way I can actually move the tent pole and start to have an effect on that, pushing up, whereas I have the points, which are actually pulling down and adjusting this really nice canvas structure. And you're going to go into that and basically use, very good idea in Grasshopper 1 to use your bifocals tool, springs from line, springs from line, springs from line, springs from line, and then your Kangaroo solver. And Entwine is a tool that they encourage to use instead of mesh, because it maintains your data structure and then it pulls back out your exploded tree with the same data structure. So that's something definitely thinking about working with. Now that was 28. We will go to 29. And like I said, these are all ones I found online. I'm not trying to get credit. I'm not trying to put these on Patreon. I just want people to know that these scripts really motivated me, and they'll be on my GitHub available. And you can get all these online anyhow if you knew where to look. So 29, second last one, is a really nice solver for Kangaroo that, if I think about it, I think I have to set this over to 1. I want to put that to false. I then want to hit play, and then when I get things up and running, this one, to see it, where is it? I might have to reset it again. 1 second, off, yeah, and then set it to false. It should be ready to set, and then I can kind of bend this up. This is a bend one, which is really nice. As I pull it up, you can see that the anchor points work and the rest try to float up in the air, and you get this kind of weird little paper scraggly thing. And what a thing to start jiggling and jaggling and making some wonderful geometries. So Kangaroo is definitely the one you want to use, and you see these bend curves are old. I still have it here. I'm not sure what it turned into in Grasshopper 2, but I really do like using the Grasshopper 1 because I actually learned off of that one when it first came out and when I first started playing with it. And then the last one I'm going to show is Kangaroo 30 script on this series, and this is similar, but it's using kind of the ideas of FlexHopper, those spheres being something that I can set to simulate, and then I can run that simulation, and I think if I set it to false, it'll fall across those spheres. It's a little jumbly, but it's really nice how it kind of adheres to the shapes and objects, and this one's nice because there's 3 objects they're actually pushing on it. The subtlety here is you've got your spheres, but you've got to turn them into these anchor points. And once again, to fully understand this, please put on your full names to know what's happening within the X and Y constraints, if they're actually being adhered to or not. Because things can get really funky and kind of otherworldly very fast with this. And Weaverbird's vertices components, Weaverbird's mesh edges. Obviously, if you're working with meshes, it's going to be a lot faster, and the only way possible to deal with lines and vertices, edges and vertices, to make this geometry actually work. But a nice shape, and once again, you can pull that if you liked it, I would use that data dam again when I was happy with it. And as I put that data dam through, I might want to put that through to curves. And when that's through, I've captured it. I have my curves, and I could use my, because this wasn't around when I first started using Kangaroo, so I like to add these scripts now. And this will be too big as it calculates. Oh my goodness. And we're going to put in a 0.02 slider into the node size. And we'll just take a look at this and see what it looks like. Hopefully that'll clean up. There it is. It's still a little jazzy. Still a little crazy. Subdivisions do go a little nuts. And you just got to be careful with this. They don't always work. I just didn't want to use pipe because I really wanted that really nice subdivision tool to work. But maybe it doesn't work so great with Grasshopper. As I freeze it up, there it is, all jumping and jiving. I'm going to turn my data dam, get rid of it, and go back to the original. You can see it's still jiggling and moving in some fashion. But that's it. Those are nice 10 scripts. I will continue to add in the 41 to 50 series, but the scripts that are going to be private in GitHub will run 11 to 20 and from 21 to 30. No, sorry, from 30. What are they going to be? From 31 to 40. And I'll just keep going because I have an infinite array of scripts that influence what I did. So if I go into here and just go into documents for the last 4 years, and pick, this is what you can look forward to. The ones I've made will be on my Patreon, but the ones that I've actually was inspired, I'm going way back 4 years and looking at all of these amazing scripts. We'll jump into the wind one, which is a flag, next, and that should be something to start with. So, thanks very much for watching. I will hit stop streaming and stop